Okay, review problem 1.4 concerns medical testing. Before starting the problem, I will draw the tree diagram that is associated with this problem. For the tree diagram, there is the chance of having the disease or else not having the disease. And either way, if you have the disease, you might have a positive test or you might have a negative test. Or if you don't have the disease, again, you might have a positive test or you might have a negative test. So the percentage of the population that has the disease is only 1%. There is a diagnostic test that's available. If the person is healthy that does not have the disease, the chance of being falsely diagnosed as having disease is 0.05. So that's going to be this chance right here, 0.05. While if somebody does have the disease, the chance of being falsely diagnosed as healthy is 0.2. So that's this probability here. And so with this information, we can finish off the tree diagram. So this must be 0.99, this must be 0.8, and down here must be 0.95. All right, so first off, what are the sensitivity and specificity? The sensitivity is the probability that you have a positive test given positive disease, and so that's equal to 0.8, while the specificity is the probability of a negative test given negative disease, and that is 0.95. In a perfect world, those numbers are equal to 1, but not every test is perfect. In fact, very few tests are perfect, and there's always a chance of either a false positive or a false negative. What's the chance that the test is positive? Well, the probability of a positive test, well, there's two ways that can happen. You can be on this branch here, where you have a positive disease, then positive test. So the chance of that happening is 0.01 times 0.8. The other possibility is on this branch, 0.99 times 0.05. Either of these ends on positive test, and I did this ahead of time, and if I did the arithmetic correctly, the chance of that is 0.0575. Okay, part C. What's the probability that we have the test and he has the disease? Or so, I stated that incorrectly. What's the probability that the test is negative and that he has the disease? So disease positive, test negative. So the probability of disease positive and test negative would be 0.01 times 0.2, which is 0.002. What's the probability of a negative test? Well, there's two ways of doing this. We could kind of do this the same way we did this one. You take this branch and then multiply these two, and then multiply these two for this negative test, and then add them up and see what we get. It's a lot easier if we've already done this to just simply take 1 minus the probability of a positive test. And that is equal to, I believe, 0.9425. All right, last problem. What's the probability that the test comes back positive? So I know I have a positive test. What's the probability of positive disease? Well, the probability that the disease is present if the test is positive. Okay, that's a conditional probability, so that's the probability of disease positive and test positive divided by the probability of a positive test. The probability of disease positive and test positive is going to be the product of these two, 0.01 times 0.8, divided by the probability of a positive test, which we've already figured out to be 0.0575. And so then it's just a matter of division, and if I did the arithmetic correctly, this was approximately 0.1391. And so if the test comes back positive, and we know that 1% of the population has the disease, then the posterior probability of having the disease is no longer 1%, it's more like 14%. So this number is not very large, even though these two numbers are decently large. And the reason that this number is not particularly large is because the prevalence in the population was only 1%. Had this number been larger, or if the doctor had some reason for thinking that the patient had the disease, then this posterior probability would have been considerably larger.